Okay, good evening. Today I'm going to talk something about GraphLab. I like to call it a carrier for machine learning, which is actually a framework for parallel machine learning algorithms. There's a new trend for machine learning, because with rapidly developing hardware techniques, people in the machine learning community are able to face real-world problems. They want to scale those classical machine learning problems. And in the meantime, a major focus in computer architecture is to maximize parallelism. And however, in order to extract parallelism from machine learning algorithm, we need to do more. It is not as easy as we think. We need to maximize throughput while maintaining correctness. So far, many work has been done in this very area, and there are MapReduce, DAG, and systolic abstraction, and we will examine them one by one. Okay. And first is MapReduce. It is a very straightforward abstraction. It has two main operations. One is map and the other is reduce. Map is like you partition your work into different parts and run them in order to run them in parallel. And reduce is like after you run them in parallel, you need to collect the results of those operations, of those map operations, and then commit them to make them coherent. However, MapReduce has some obvious drawbacks. First, it is only optimal when the algorithm is embarrassingly parallel. But in actual cases, many machine learning algorithms are not that easy to parallel. And it cannot deal with computational dependencies. Think about structured models like data flow graph. And it does not express sophisticated schedulings. This is because it cannot directly encode iterative computations, which is very typical for many machine learning algorithms like perceptrons or as spot vector machine. And it will incur high overhead when applied to typical clusters and multi-core settings, which are very common these days. Another abstraction is DAG, directed acyclic graph. It has some advantages, some improvement. It can support computational dependencies. But it does not support iterative algorithms like MapReduce. So